Good morning, everyone. Happy Tuesday, May 26th. Here we go with part number 2 of the Aquatic Ecosystem slideshow. Um, Short fill in the blank quiz, not a quiz, but assignment to follow. 13 marks, so hopefully everybody can get that done as soon as you can. As of yesterday, we have 58 of 70 completed the matching from aquatic ecosystems part number 1. Hopefully everybody got through the slides yesterday. Easy enough. All right, here we go. Aquatic ecosystems, day number 2 of 2. All right, so we're going to talk about on this slide the 5 categories or 5 ways that water is polluted. Okay, most common down to still important, but the least abundant or least common found. All right, number 1, we have the organic solid waste, and this is sewer water or sewage waste from food processing plants, etc. All right, this uses up the oxygen in the water, which causes living things in the water to die because of that. Okay, number 1, organic solid waste. Then we have the disease causing organisms. And these organisms are found in animal waste. We got the cow, the pig, the horse waste. Okay, their sewage. Okay, this triggers the outbreak of waterborne diseases. Okay, or disease-causing organisms. Followed by number 3, inorganic solids. These are the human-caused ones right here. Mining, excess fertilizers, salts we use on our roads will run off into bodies of water, inorganic solids. Then we have the thermal energy. Okay, this causes thermal pollution, increased water temperature due to electricity generating plants. Okay, this decreases the solubility of water, which also decreases the amount of oxygen in the water, kills living organisms in it as well. Number 5, organic compounds. All right, oil from roads, excess pesticides, um, farmers use, for example, detergents. All right, organic compounds. 5 ways or 5 categories of water pollution. All right, our last few slides, we're going to talk about the 4 seasons here and how our water is affected and living organisms within it. Okay, it seems kind of weird that winter is number 1, probably the most common of the seasons within our province here or Canada. All right, um, we got winter. All right, everyone knows that we have a layer of ice that will be found or formed on our lakes in the winter. Okay, this acts as a shield over the water. This blocks the sun, reduces the photosynthesis of any living plants. Okay, the photosynthesizers within the water. All right, this cuts down on the oxygen, lowers the amount of oxygen available to organisms living in the water that need it. Okay, and um, this is what our layer of ice does to living things inside it. Okay, so temperatures at the bottom of the lake in the winter, 4 degrees Celsius. That's pretty cold. All right, temperatures just below the ice. Okay, we got 0. Water is the most dense right here. Okay, 1 degree, water is the most dense, which is why the ice, which is 0 and less dense, floats on top. Okay, 4 degrees, 1 degree, most dense. We got 0 degrees or even colder on the top. Okay, second season, which we're currently in the midst of, is spring. Okay, this is pretty obvious information. Spring melts the surface ice, all right, and this disappears in the spring, this ice. Okay, water is exposed to the air once again, which returns the oxygen to the water. Okay, so we got wind stirring the water, causing the oxygen to go down. Okay, this is called spring overturn. Okay, as water surface heats up, it sinks because it is more dense. Okay, and that causes this spring overturn. Okay, so wind and the density of the water or warm water, okay, causes this turnover or spring overturn. Okay, this returns the oxygen to the water. Followed by my favorite season, probably most of yours as well, we have the summer. Okay, three lake layers form in the summer. Okay, and it's difficult for oxygen and other materials to exchange with each other in these layers, okay, due to the differing temperatures. Okay, so the epilimnion, that would be this top layer, okay, the upper level of the lake, is roughly around 20 degrees. Okay, pretty comfortable swimming weather. All right, the thermocline, very small, thin layer. Okay, this is a layer between the warm and the cold. Um, right here, known as the thermocline. That's just this white line that goes through, very thin. Okay, then we got the hypolimnion, that would be referred to as the cold layer or the lower level of the lake. Okay, extremely low temperatures. Epilimnion, thermocline, hypolimnion. Okay, um, two of the above layers have problems in maintaining the oxygen content. All right, I will leave that with you to guess which two layers do you think have difficulty maintaining the oxygen content. All right, but here is a big hint for you. Cold water holds more oxygen. Okay, if you look at this graph right here, the colder the temperature, okay, the higher the amount of dissolved oxygen. Okay, warmer. Now our water will never get this warm, but if it did, very small amount of oxygen. Okay, cold water holds more dissolved oxygen than warm water. All right, moving on to the third season of 4, we have the autumn or the fall season. Okay, once again, it's getting colder, water's getting colder, the water or in the lake is being turned over again. Okay, air temperatures cool, causing a change in the density. All right, so oxygen once again gets flowing around. Okay, Arctic lakes, because it's so cold, will freeze in the bottom. Okay, we got the more dense water up here. Okay, less dense water down here due to the temperatures. And in the fall, this is changing and switching around. Okay, it gets colder up at the top. All right, moving on. Let's talk about a few organisms that live in um, each of those 4 seasons. Okay, each lake has specific changes in temperature that is pretty common sense. All right, um, the amount of temperature determines the amount of oxygen levels. Okay, many types of fish can adapt to some lakes and others. Okay, salmon, for example, need high oxygen levels. Okay, carp is an example of a fish that can live with much less oxygen. Okay, then we have the lungfish. These guys are pretty cool. All right, they have gills and they have lungs. All right, born with gills. As they grow up, all right, they get lungs. All right, they are found in Australia. All right, oxygen levels are also decreased by decomposition. So we have decomposing things on the floor. All right, increased pressure decreases oxygen levels, as do chemicals and other salt. Okay, now this last slide, real quickly, talks about the effects of um, logging, cutting down trees, and transporting of these logs, okay, by water. I don't know if you've ever seen by a pulp mill. There's a lot of logs floating in the water. Logging increases the nutrients from decomposing bark, etc. Okay, speeds up the growth of plants, increases the growth of plants. Okay, this increases the amount of decomposition. This eventually leads to reduced oxygen levels. So everything humans are doing is reducing the oxygen levels in lakes, unfortunately. Okay, so these are the effects of not only logging, but the transport of these logs by water. Okay, here's an example of thermal pollution that was we mentioned earlier. Lake Wabamun has an uh, electricity producing plant. Okay, where it's really warm, people swim in it. But unfortunately, with this increased water temperature, there's an increased growth of plants, lots of seaweed, lots of plants there. All right, this increases the decomposition and lowers the oxygen level for the fish that live in there. Okay, also the living plants in there. All right, this eventually results in the death of these organisms. So eventually, all living things are going to die out of this Lake Wabamun due to the electricity producing plant. All right, that's a wrap. Day number 2. Have a great Tuesday, everyone. Hope you have an amazing day.